In this video, we'll apply some of the concepts that we've learned in this section to solve a problem. What we'll do first is we'll solve the problem using literal constants, and then what we'll do is we'll refactor it to use declared constants. And along the way, you'll see how much better it is to use declared constants. Okay, so here's the problem we're going to solve. Frank has a carpet cleaning service that charges $30 per room, and there's a sales tax rate of 6%. All the estimates are valid for 30 days. So our program is really simple. We're going to prompt the user for the number of rooms they would like cleaned, and we're going to provide an estimate. The estimate will look something like this. You can see here starting at line 13. Estimate for carpet cleaning service, number of rooms, 2. That's the number that the user entered. Price per room, $30. Cost, $60. Obviously, that would be $30 per room times 2 rooms. The tax, which would be 6% based on the $60, which would be $3.60. Then the total estimate would be $63.60, and then you print out this estimate is valid for 30 days. Now I'm using dollars, you could use euros, you could use any currency you like. Also, I know that the formatting isn't right. Obviously, $3.60 would be 3.60. Don't worry about that right now. Let's worry about solving this problem and using literal constants and using declared constants. We'll worry about output formatting in a different section, and we'll go over a bunch of different ways to do formatting, including currency formatting based on your locale. All right, so let's think about how we're going to solve this problem. Programmers often use something called pseudocode. Pseudocode is like an English-like or your own natural spoken language-like representation of the algorithm or the steps necessary to solve the problem. In this example, I wrote down some pseudocode. And pseudocode, don't let anybody tell you that there's a right way and a wrong way to do pseudocode. There really isn't. It's not a programming language. This is something that organizes your thoughts and allows you to solve the problem. Remember, if you can't solve the problem in pseudocode, there's no way you're going to solve it in C or in Java or in any other programming language. So in this case, this is my pseudocode. These are the steps that I want to take to solve this problem. The first thing I want to do, and you can see here on line 23, is prompt the user to enter the number of rooms. Great. I want to display the number of rooms to the user, display the price per room. Then I want to display the cost, which is the number of rooms times the price per room. I want to display the tax, which is the number of rooms times the price per room times the tax rate. Then I want to display the total estimate. The total estimate, of course, is the cost plus the tax. And then I want to display at the end, this estimate is valid for 30 days. So what we want to do is we want to mimic this sample output right here. Okay, so let's get started. What we'll do first is we'll do this using literal constants, and then we'll refactor it using declared constants. So the first thing I'm saying is, hello, welcome to Frank's carpet cleaning service. That's my little introduction. Now I need to ask the user, again, look at the pseudocode, ask the user how many rooms they'd like to be cleaned. Okay, so let's do that. We'll say cout, and we'll say how many rooms would you like cleaned? And I'm going to type this along, and if I make typos and errors, that's fine. I'll fix them along the way, and you'll probably make the same kinds of errors, so you'll see how to fix them. Semicolon at the end, and there's a typo right here. So how many rooms would you like cleaned? Now, let's run this. And what I'm doing is I'm pressing Control F5, which is build and run. And you can see here, hello, welcome to Frank's carpet cleaning service. How many rooms would you like cleaned? Perfect. Now I'd like to put a space between the first line and the second line of output. Now there's a couple of ways I can do that. I can come down here and I could just add another end line, and that'll print 2 new lines at the end, which would be fine. I could also just say cout end line here, which prints out a line. Let's run that and I'll show you what that looks like. Now you can see that there's a line between the first line and the second line. And I can also use a character literal constant right here. And in front of the how, I can put a /n, a \n. That's a new line. Now I can get rid of this, and it has the same effect. So what's going to happen here is it's going to print a new line before it prints the how. So if I run this now, you can see I get the same effect. So this is an example of embedding those escape codes, as I mentioned in the PowerPoint slides, into string literals. So now we're here. Next step is to read in the number of rooms from the user. So obviously we need to use the extraction operator with the cin object, but we need to store that somewhere. So let's create an integer. We'll create a variable here, and we'll call it number of rooms. Best practice is to initialize it, so I'm going to initialize it to 0, and cin, and let's get the number of rooms from cin. Okay, so again, let's see where we're at. We've outputted our prompt, and the user has entered the number of rooms. Now we've got all the information that we need to do our calculations. We know that it's $30 per room, and we know that it's a 6% tax rate. That's all I need. So let's create some output statements, and I'm going to close this down here just to create a little bit more room. All right, so let's go here, and we're going to say cout, and let's put a /n here too, because I'd like a space right here. So I'm going to say estimate for carpet cleaning service. We'll create a new line here. Now we want to display the number of rooms to the user. I'll say number of rooms. And I'll put a $sign in here. I'm not too worried about the formatting. I'm just using dollars, so I might as well put the $sign here. And I want to display the number of rooms. Where do I get that? Well, I get that right from here. That variable right there, the user just entered a number and I stored it in there. So that's going to contain whatever they entered. So there's number of rooms and then end line. All right, let's run this. Control F5. And I've got an error that says I forgot to put an L at the end of the end line. There we go. So let's run this again. How many rooms would you like cleaned? Let's say I want 2 rooms cleaned. Estimate for carpet cleaning services, number of rooms 2. I don't want $1 there. I want $1 for prices. So that I'll fix that error. 2 rooms. Perfect. Okay, so now let's start doing some of the calculations. But first, we need to print out the price per room. And that's a given. That was given to us as $30. So we'll say price per room. Here we'll put a $sign. And we'll say 30. We'll use a literal right in there. And we'll say end line. All right, so that's it. Then we'll say, what's the cost? Well, we'll have to do a calculation. So we'll say cout would be cost. And again, I'll put a $sign in here. And what's the cost going to be? Well, the cost is going to be 30 times the number of rooms, right? $30 per room times the number of rooms. And we'll put a new line at the end. Let's test this out as we go. So let's run it. I want 2 rooms cleaned, so I expect the cost at this point to be $60. So 2 rooms, $30 per room, costs $60. So we're good. All right, so let's continue. And we'll say cout, what's my tax? Or my sales tax is, again, I'll use $. And my sales tax is going to be the same calculation, right? 30 times the number of rooms. And I've got an extra quote character right here. Let me get rid of it. 30 times the number of rooms times 0.06, which is the tax rate. End line. I'll save this. Let's run one more time. 2 rooms cleaned, $30. It's $60. 6% of 60 is $3.60. Okay, so we're good. Now we're going to calculate the total estimate, which is going to be the cost plus the tax. But first, I just want to print out a nice little line that separates everything together. That's long enough. And I'll put an end line at the end. All right, so now let's say what the total estimate is, and then we just need to say the estimate is valid for 30 days, and we're done. So cout, we'll say total estimate, and again in dollars is going to be, okay, we need to do the calculation again. So we're going to say 30 times the number of rooms, which gives us the cost, right? And I'm going to put some parens around that because I need to add to that plus 30 times the number of rooms times 0.06, which is my sales tax. So that's my cost plus my sales tax and a new line at the end. Last thing is, let's say cout this estimate is valid for however many days, and we said 30. And I'll put a space in front of the D just so we have a little room. Another line here, and I think we're good. Let me clean this up a little bit down here so it all fits a little better. All right, so let's run it, and then we'll go over it real quick. I'm going to save it and run it with Control F5. How many rooms would you like cleaned? 2 rooms. Number of rooms is 2. The price per room is 30. The cost is 60. The tax is 360. So you would expect the total estimate to be 6360, which it is. This estimate is valid for 30 days. Cool. Let's try it again. Let's run it again with 1 room this time. 1 room is $30. The cost is $30. The tax is $1.80. Total estimate $31.80. So it looks good. Don't forget to test with 0. So 0 rooms cleaned, 0 cost, 0 tax, 0 estimate. Great. Don't worry about testing with illegal values. We'll learn how to deal with illegal values later. So for example, expect it to users going to type 0 or something positive in the number of rooms. They're not going to type in -1 or Joe or Frank or anything like that. As I said, we'll deal with exceptions as the course progresses. So that's it. That's the program. It works. It's pretty easy to understand. It follows our pseudocode, but there's a couple of issues here. First, suppose that I want to increase my cost per room or my price per room to $32.50. What do? Well, I could do a search and replace, right? Let's do that. I'll do a search, find and replace, and I want to look for 30, and I want to replace it with 32.50, and I want to do it everywhere. Replace all. Done. I'll close this up, and let's run it. So I want to do 2 rooms. 2 times 32.50 is 65. That's correct. The tax is $3.90. That's correct. The total estimate is correct. Looks good, right? Except for one little thing. This estimate is valid for 32.5 days. You can see that the 30 was replaced with 32.5. I didn't want to do that. So I need to go back to my code, and let's change that to 30. And now we're okay. This is easy to fix in this example because it's really small. But if you've got thousands of lines of code and you're doing search and replaces like this, it's real possible that that 30 is going to be in different places and it doesn't represent price per room. It represents something else. And you just really messed up your program. You made a lot of changes you didn't intend to change. So hopefully you'll see what I mean. I'm going to undo this 30. And I hope I'm back to where I was. Yep, I'm back to where I was with 30. What I want to do here is I want to use declared constants rather than these literal constants. So let's do that. First, let's just create the variable, and then we'll make it a constant. So we need something for the price per room. So let's create that. Let's say int price per room, and we can initialize it to 30. And then the idea being, instead of using 30 here, we'll use that name price per room. Okay. That's okay, but why an integer? That's really doesn't make too much sense, right? It makes sense with 30, but if I change the price per room to 32.50 or some real number like that, a floating point number, this won't work very well. So this really should be a double, and I'm going to change that right there. That gives us a floating point number, and the last thing I want to do is I want to make it const. I don't want that to change in my program. I'll always want it to be 30 while this program's running. Okay, now if I try to change that right here, I'll just show you real quick. Price per room, let's say I want to change that to 100. And I'll just compile over here. I'll get a compiler error that says error, assignment of read-only variable price per room. You just told the compiler that price per room is constant, and here you tried to change it. The compiler is saying, no way, you just told me that this should not be allowed. Okay, so that's one of the benefits of constants, as I mentioned in the lecture. So let me get rid of that. And so that's one of the constants we need. We also need another constant. I'll put a 30.0 in here to be more accurate because it is a real number. I need another one for the sales tax. So I could say const, again, double, And I can say sales tax or sales rate or whatever you want to call it. And in this case, it's 0.06. And then finally, let's create another one for the estimate expiry, which is the 30 days. Const, this case could be an integer, and we'll just say estimate expiry. And we'll initialize that to 30. And this would be a good place for a comment, days. Okay, so now we've got those three constants. What we can do now is, let's go through our code and we'll replace that 30, for example, with price per room. That 006 with sales tax and so forth. This is called refactoring your code. Refactoring means changing your code to make it better without changing behavior. That's real important. Refactoring does not change the behavior of your code. It just makes your code better, more modifiable, easier to read, and so forth. So let's do that. I'm going to use price per room here. I'm just going to copy it. And I'll paste it in here, I'll paste it in here, I'll paste it in here, in here, in here, and not in here because that's my expiry. I'll take sales tax, I'll copy that, and I'll paste it here, as well as over here. And then finally, we'll do the estimate expiry right here. All right, so now let's run this again. And the behavior should not change. I want 2 rooms cleaned. 2 rooms at $30 is $60, $360 sales tax, $63.60 is the total estimate, and it's valid for 30 days. Perfect. As you can see, this code is much more readable now. You can actually see what's going on. And more importantly, if I want to change the price per room to $32.50, I only have to do it in one place right up here. So I can make this $32.50, save it, build and run again. 2 rooms, $32.50, which is $65 now is the cost, $390 tax, $68.90, and it's still valid for 30 days. So you can see the benefits of using declared constants. You can just make changes in one place. You're guaranteed that they're not going to change even if you made a mistake and it was an accident. And it makes your code so much more readable and modifiable. Now, although this code is much better now after refactoring, it still has a few problems. And those problems we're going to address as the course progresses. You hopefully have seen that right about here, we're doing a calculation. And then right here, we're doing the same calculation again. And here, we're doing the same calculation again. And here, we're doing it again. Okay, so that's 4 places that we're doing the same calculation. That's 4 places we could mess up. We really don't want to do that. We want to do that calculation exactly in one place. And what we'll do is when we learn about assignment statements and a little bit more about mathematical expressions, we'll do that there. And then a little bit later in the course, we'll use functions to do that in exactly one place. So if you notice that this isn't quite right, you see a lot of duplication of code, you're absolutely right. And we're going to handle that as we go.